So hello students, now we'll discuss leftist tree, but this tree is little bit different. This is minimum leftist tree. Okay, so what is meant by minimum leftist tree, that we have to see first. So in the previous lecture guys, we discussed what is leftist tree and how to identify that the leftist tree, the tree is leftist tree or not. Okay, so for that you have to just satisfy one property. S value of left node is greater than equals to S value of right node. That you have to identify first. Then only you can say that the given tree is the leftist tree. Okay. Now so guys, first of all, here they are given two trees. Now they are asking whether these two trees is minimum leftist tree or not. So what is meant by minimum leftist tree? Okay. So first thing is you have to satisfy the leftist tree property. Okay, the formula that we discussed, that you have to satisfy. Okay, so first of all, see this 13 is the leaf node, so we need not to worry because both the children is external node. 11 is having S value, that is 1, and one external node is there. Okay, so you need not to worry. The left node S value is greater than equals to right node S value. Okay, so left node S value is 1, right node S value is 0. That's why 1 is greater than equals to 0. So this is valid. Okay, so this node is valid. Similarly 7 is having S value 1. Okay, both the children, left children is S value is 1 and right children S value is 0. Okay, so this is also valid because 1 is greater than equals to 0. Then comes to 80 guys. 80 is having both the children external nodes, so this is a valid node. Then 50 having a left node, but the right node is external node S value is 0. That's why 1 is greater than equals to 0, so 50 is valid node. Then comes to 2. So 2 is having two childrens and both the childrens is having S value, that is 1. Okay, so 1 is greater than equals to 1, so this is valid. Okay, it means this is leftist node, a leftist tree. Come to the second tree guys. In the second tree also, this is valid node, this is valid node. Then 1. Okay, so 1 means 1 is greater than equals to 1, this is valid node. Then 2 is greater than equals to 0, so this is valid node. 15, this is valid node because both the children is external node. Then 10, 1 is greater than equals to 0, so this is valid node. Then 8, 1 is greater 1 is greater than equals to 0, that's why this is also a valid node. 8 is valid node. Then comes to 5 is having two children, both the children having S value, that is 1. Okay, so 1 is greater than equals to 1, that's why this is a valid node. It means both the trees are leftist tree. Now guys, we have to check whether both the trees are minimum leftist tree. So what we have to see, in the minimum leftist tree, every root is having less value than its children. Okay, every root node, okay, that root node might be in the subtree also or might be in the complete tree. Okay, every root node is having minimum value, less value than its children. Then we can say that that tree is called minimum tree. Okay, or generally we called it as a minimum heap. But now here we are discussing minimum leftist tree. So we'll say that tree is called a minimum leftist tree. Okay, so first of all you have to satisfy the property of leftist tree, then you have to check this. So guys, 11 is less than 13, so valid. 7 is less than 11, so valid. 2 is less than 7 and 50. Okay, so valid. 50 is less than 80, so this is valid. 80 is the left node, so no need to check. Then here come to second tree. 12 is less than 20 and 18, so this is valid. 9 is less than 12, so this is valid. Then 15 is the leaf node, so no need to check. Then 10 is less than 15, so this is valid. 8 is less than 10, so this is valid. And 5 is less than 9 and 8, that's why this is valid. So guys, both the trees are basically what? Minimum leftist tree, because these two trees are satisfying both the property. Which property? One is leftist tree property and second one is minimum property. Okay, means the root node is holding less value or minimum value than its children. Okay, so guys, you can observe here this is the root. This root is having minimum value than all its children's. Okay, see, this is the root 55, sorry. This 5 is less than of its all the children. Okay, that's why this tree is called as minimum leftist tree. Okay, so I hope you are getting my point, guys, how we can identify the minimum leftist tree and how we can identify the tree is given which is leftist tree or not. Basically you have to satisfy that formula. Okay. Now guys, what they are asking, meld the given minimum leftist tree. See guys, there is a maximum leftist tree also. Okay, in the maximum leftist tree, what is the thing that we have to observe? Every root node is containing maximum value than its children. Okay, every root node is holding maximum value or greater value than its children's. Okay, that is maximum leftist tree. But now guys, they are giving here minimum leftist tree. So now we'll discuss how we can meld this given minimum leftist tree. Okay, meld this means merging. Okay, means you have to create only one leftist tree from both the trees. Okay, means you have to merge both the trees. Okay, so how we can merge? Okay, so first of all, this is minimum leftist tree. So you need to identify, there are two roots given here. So you need to identify which root is the smallest root. So this root, this 2 is the smallest root now. Okay, see this process is very carefully, guys. This is a recursive process. Recursive process means whatever the thing you are doing here, that thing you have to do again. Okay, because at the time of recursion, our function calls is basically a backtrack call. Okay, means you are doing a function call multiple times and after you are getting a null value at the end, again you are getting means reverses back. Okay, means whatever the value sent by that function that you have to reverse to the previous function call. Okay, so this is very important step. Okay, you need to observe this. So first of all, this is minimum leftist tree. So if they are saying that this is minimum leftist tree, so you have to identify which root is minimum root. So here, in this case, 2 is the minimum root. 2 is the minimum root. So what I will do, I will call one function for the right subtree for this leftist tree. Okay, right subtree for this leftist tree. Okay, whose root is minimum in this case. Okay, and the other tree I will pass as it is. Okay, so guys, see, I will call one merge function for this right subtree. Okay, so what I am doing here, I am cutting this right subtree and I am calling the merge function. Okay, and in this merge function, guys, I will send this 50 and 80. Okay, I will send this 50 and 80. The remaining tree is as it is, guys. Whenever we will come back, in that case, guys, I will take care about this tree. Okay, now you need not to think about this tree. Okay, this part of a tree. Okay, now you are sending this part of a tree. Why you are sending this part of a tree? Because this tree's root is minimum. Why we are looking for the minimum root? Because this is minimum leftist tree. Okay, if they are asking maximum leftist tree, in that case I will take care about maximum value of the root. Okay, but now they are asking minimum leftist tree. And the second tree we have to pass as it is. Okay, so second tree I will write as it is. Okay, so this is my second tree. Okay, so see guys, I am writing this diagram in first half of this page. I am writing this for diagram on the first half of this page. I will use this space later whenever I will come back. Okay, in my function call. In that case, guys, I will use this space. Okay, so in the exam also you have to keep this space blank. Okay, so what you can do, you divide your page in the two part. In the first part, you have to do this step, whatever the step I am doing here. And in the second part, you have to show the arrows. You have to show the arrows like this. Okay, like this we are solving this problem. You have to show. Okay, and in the second part, whenever we will come back, okay, while doing this function call, that part we have to show here. Okay, so now we are doing the function calls. So just see here, 12, then 20, then 18, then 10 and 15. Okay, so see, after first function call, guys, I got this tree and this tree. Okay, now again, guys, I will compare both the root. I will compare this root and this root. Which one is the minimum root? So this 5 is the minimum root. So now I will send this subtree, this right subtree of this minimum root, this right subtree of this minimum root to the next function call, that is merge. Okay, so now we are not doing any merge, guys, but whenever we will come back, at that time we'll do merge. Okay, now I am not doing any merge. Okay, if the right subtree exists, then only I will call the merge. If the right subtree is not exist, where right subtree is null, in that case I will return null, and then I will come back by doing the merge. Okay, now guys, so here I will get what? So this tree is as it is, 50, 80 as it is, and now here I will get 8, 10 and 15. So guys, see how I am writing this tree, same. Okay, so 8 left node is 10, left node is 15, 8 left node is 10, left node is 15. Okay, while writing, if you make this 15 as a right node, then it will make a different example. Okay, then your answer will be wrong at the end. Okay, so that's why take care while writing the tree, guys. You have to see whether you are writing a left node or right node. Okay. Now guys, again compare both the trees, roots. 8 is a minimum root. 8 is a minimum root. But the issue is the right subtree is null now. The right subtree is null. The right subtree is null. It means now whenever the right subtree is null, you cannot call a merge function, or if you are calling the merge function, let us assume that if you are calling this merge function, so what you will get? You will get 50 and 80 here, 50 and 80 here, and here you will get null. Here you will get null. Now you have to perform the merge operation between this. Okay, you have to perform the merge operation this, but the right subtree is null, so it returns null. It returns null. Okay, so guys, what I have to do, if it is returning null, now I have to do a merge function or merge thing. Okay, now I have to take care about merge thing. Now, so see this very carefully, guys. So guys, in this function call, I am sending null from this tree. Okay, why I am sending null from this tree? Because this tree's root is minimum. This tree's root, if I am comparing these two trees, the root of this tree is 50, the root of this tree is 8. Okay, so this is the minimum. This is the minimum root. Okay, that's why I send this null here in the next merge function call. Okay, but now guys, this null is returning what? Returning null. Okay, so now I have to do the merge. So this tree is sending null. Now I will do the merge operation between this and this tree. Okay, so I will merge this tree with this tree, because this tree is having a minimum root, and because of this minimum root, this tree calls the merge function. So I will merge this 50, this tree and this tree here. Okay, so how I will merge? It's very easy, guys. First of all, you need to write 8, 10 and 15, and now you have to merge this 50 and 80 here, direct, simple. See guys, this 50's left child is 80, that's why here I am writing 50's left child is 80. Okay, 50's left child is 80. Is this a 50 or 20? It's a 50. Okay. So 50, left child is 80. Okay. Now guys, after doing this, okay, so whenever you are doing the merge operation guys, see this part you are sending here, this part you are sending here. So only this part you have to merge. Here only you have to merge this tree. Okay, here only. Which part you are sending, there only you have to merge this. There only you have to merge this. Okay, that's why I am writing 50 and 80 here. That's why I am writing 50 and 80 here. Okay, because I am sending this part. Because I am sending this part. Now guys, come forward. Okay, one more thing. After merging guys, after merging you have to check whether this tree is satisfying the leftist tree property or not. Okay, so guys, that's why here I am writing the S value of this node. This S value of this node is 1, S value of this node is 1. Why? The 10 S value is 1 because one of the node is external node. So here you have external node, here you have external node. So that's why the S value of this 10 is 1. Okay. Now similarly, what is the S value of this 80? S value of this 80 is 1. What is the S value of this 50? S value of this 50 is 1. What is the S value of this 8? S value is 2 because both the node is having S value 1 1. So minimum is 1. 1 plus 1, that is 2. Okay. So guys, check whether it is following the property of leftist tree. Yes, I think so. It is following the property of leftist tree. Okay, so this is 1. This is following. This is 1 because 1 is greater than equals to 0. So this is following. 1, this is leaf node. So it's following. Then 1 is greater than equals to 0 because this 50 is having one external node. So 1 is greater than equals to 0. So this is following. And again, this is following because 1 is greater than equals to 1. Okay. So this tree is the leftist tree. So we need not to worry. If it is not following the leftist tree property guys, then we have to act differently. Okay, that I will show you in the next step. Okay, now come forward guys. Next. Okay, see, now I am going upward. Now see, I am going upward. Okay. So guys, up to this part we have done. Up to this part we have done. Okay. Now guys, come to next. This part. Come to this part. Okay. So see, we are sending or we are calling our merge function for this tree, for this right subtree. So whatever the tree we got here, that tree we have to merge with this. Okay, because for this trees, right tree we have sent. Okay, so what I will do now, I will write this tree here as it is. I will write this tree here. So 5, 9, 12, 20, 18. Okay. And on the right hand side guys, whatever the new tree we got here, that tree we have to merge here. After merging we will see whether it is following the leftist tree property or not. If it is not following the leftist tree property, then what we have to do, that also I will tell you. Okay, so first of all what I am doing, I am just writing this tree here. Okay, same you have to write here guys, same. Okay. If it is a left child, then you have to write left child only. If it is a right child, then you have to write right child only. Okay, otherwise you will get the different answer. Okay, so this is done. Now guys, calculate the S values of all. S value is 1, 1. Then here the S value is 2, S value is 1, 1, 1, 1, 1. Here the S value is 2, here, Now here the S value is 2. But guys, you can observe here, see. Observe this part. The S value of left node is 1 and S value of right node is 2. Okay, this is the violating the property of leftist tree. Okay, because what is the property of leftist tree? The left node S value is greater than equals to S value of right node. But here the right node S value is greater than left node S value. Okay, so what I have to do, I have to swap, means whatever the merge operation I did, that merge operation I have to swap. Okay, swap means instead of writing this 8 subtree on right hand side, we have to write this 8 subtree on left hand side. Okay, or left subtree I have to write. Okay, so for that what you have to do, see here very carefully. So now this is 5. Okay, so what we did earlier, we write this 8 subtree on left hand side. Now I will write this 8 subtree on, we write this 8 subtree on left hand side of 5, but right hand side of this 5. Now I will write this 8 subtree on left hand side of this 5. Okay, so what I am doing here I am writing this subtree. See very carefully. Okay, now like this. Now what about this 9, 12, 20 and 18? What about this 9, 12, 20, 18? Okay, so now we have to write this on the right hand side. Okay, so earlier it is on left hand side, but to make it leftist tree, we are writing this on the right hand side now. Okay, so now I will write this 9 here, 12, 20 and 18. Okay, I hope you are getting my point, guys. So now guys, check whether this tree, newly created tree, is satisfying the property of leftist tree or not. Okay, so again I will write the S values 1, 1, 1, 1, 1, 2, 1, 2, this is 1, and now you can observe guys, 2 is greater than equals to 1, so now here I will get 2. Okay. Now guys, you just see whether it is following the property of leftist tree or not. Okay, if it is following the property of leftist tree, then this tree is valid. So guys, as per my conclusion, this tree is satisfying the leftist tree property. Okay, now next, one more function call is still left. Okay, next. So guys, earlier we sent this 5080 to the next merge function. Okay, merge function, this 85020 to next merge function. Okay, now I will add whatever the tree we got on this tree or on the left hand side of this tree. Okay, so let us assume that if I am drawing this tree here, so what I will get? Here I will get 1, here I will get 2. Okay, this 2 becomes this 2 is here only. Okay, then again this will not satisfying the property of leftist tree, because 1 is not greater than equals to 2. 1 is not greater than equals to 2. Okay, so again we have to do swap operation. Okay, so either you can merge this tree here first and then you swap it, or directly you can swap. Okay, so here I don't have a space. What I am doing, I am directly swapping. Okay, so what I am doing here, I am writing this 2 here, 2. Then directly I am writing this 5, this subtree on the left hand side directly, because I know if I write this 5 subtree on right hand side, it will violating the property of leftist tree. That's why directly I am writing it on left hand side. Okay, or you can show one extra step. First you add it on right hand side, then show that it's not satisfying the property of leftist tree, and then again write one tree where you are writing this subtree on right hand side, left hand side, sorry. So now here you will get 9, here you will get 10, 50, here you will get 15, here you will get 80. Okay, now guys, this is 12, and 12 is having 20 and 18. Okay, now whatever the tree is left here, that I will write on the right hand side. Okay, So now I am writing here 7, 11, sorry, this is not, 11 is not on this side. Okay, 11 is on this side. Okay, so be careful guys, while drawing the tree, be careful. Okay, if it is the left children, then you have to write left children only. If it is the right children, you have to write right children only. Okay, so guys, check whether this is the leftist tree or not. So here I am writing the S value of each node. Okay, so here I am writing the S values of each node. Okay, so I think this is a leftist tree because it satisfies the property. It satisfies the property of leftist tree. So guys, this is your ultimate answer. Okay, after merge. After merge. Okay, this is your final answer. So now you can find out whatever the nodes you have here, all the nodes are present in this tree, and this is your final minimum leftist tree. Okay, why it is minimum guys? So you can see your minimum node is at the root. Your minimum node is at the root, and rest of the node is greater than your root. Okay, so you have to check this minimum property for each and every root of subtree. Okay, so guys, I will take one more example of